Let's take a look at basic graphing on a TI-Nspire CAS. Now, first one we'll take a look at is y is equal to x. Now, I know a lot of these basic building blocks are going to be pretty simple, and you already know what the graph looks like. But that isn't the point. The point is learning all these basic building blocks on your TI-Nspire CAS, so that later on, when the problems become more complex, those problems will just be a mixture of these basic building blocks. So if you got these basic building blocks down, you'll be able to graph those. Okay. Now I'm going to press the home button, so we all start at the same place. So this is what you should see. And I'm going to down arrow to graph. You can also, I believe, push the screen. I got a couple of these. I haven't used them forever, but I didn't have much luck myself. Actually, I don't think you can push the screen. Another thing about this is like a mouse. This right here. But anyway, I down arrow to highlight graph and press enter. Now I'll press escape on that. I don't want that up to begin with. I do here shortly, but escape. Okay. Now you should see F1 there. If you don't, press tab, and then you should. Pressing tab alternates back and forth between them. So if you press tab enough times, you can see F1. Now to press the graph of y is equal to x, we want to just push our x key, which is down here. And then, if I just press enter, it automatically graph for you. And that'd be your answer. Now let's say your window's kind of screwed up. You've zoomed or something, you're not quite seeing that. If you press the menu, you see the fourth one, it says window zoom. I didn't mean to put mouse over that. What you can do is you can down arrow to that line, window zoom, and then you press your right arrow. You can also press the numbers in front of it. Like if I press 4 and then choose zoom standard, if I did 4 and then 5, it would automatically do this. But I press the right arrow key to bring up the submenu. Now I'll down arrow and highlight zoom standard. So again, we want to choose window zoom and then zoom standard and press enter. This sets your standard viewing window from -10 to 10 on your x-axis, and on this particular calculator, -6.43 to +6.43 on your y-axis. Let's take a look at y is equal to x squared. I'll press tab. Okay, there. Press tab to go back to the F1. I had put my cursor on one of these, and so it kind of went off. But now I'll do an up arrow, choose F1. Now you can press this delete to delete the previous entry, whether it's a character or exponent or whatever. And I want to do x squared, so I do my x key, and I push the x squared button. And now if I press enter, then that's our answer. Well, let's take a look at how to graph y is equal to x to the third. And specifically, I'm demonstrating how do you handle it when you get any number up in your exponent. Third power, fourth power, fifth power, 20th power, whatever. I'll press tab to go back here, do my up arrow, choose F1. Instead of pressing delete, you can do a control and then it's delete to get to clear. And that clears out the entire line, not just your previous entry. And then we'll do x. Caret is how you do the exponent. Now once I do the caret, you notice it throws it up in exponent mode. So when we put 3 in, we're still in exponent mode. The trick is you got to remember to do a right arrow key to get it out of exponent mode. Now I didn't need to do that for graphing purposes, but it's just good practice, because if I had anything else, like if I had x to the third minus x squared plus 1, I have to make sure I do the right arrow key to get it out of exponent mode. Anyway, if I press enter, then it gives us our graph. Now let me demonstrate that. Let's say I was graphing something more complex. I press my tab, up arrow to F1, and if I press delete one time now, didn't feel like it did anything. Press one more time, gets rid of the third power. One more time, gets rid of the x. So each time you press delete, it gets rid of one more entry. If I press delete one more time, it even gets rid of the equals. which isn't what you want. Not yet. We'll look at these eventually. To choose the equals again, we press 3, and it'll put the equals back for you. Okay, let's say I'm going to do x to the third minus x squared minus 1. So I do x key, caret 3. Now we're currently in exponent mode, so I want to make sure I do a right arrow key to get out of exponent mode. Minus x squared and minus, let's say 1. And then press enter. Excuse me. And now it'd give us our answer. Now let's say I didn't do a right arrow key to get out of exponent mode. You go to tab, up arrow, do a control delete to clean all those out. And I do x caret 3. I'm still in exponent mode, but let's say I don't do the right arrow key. Then minus x squared minus 1. And press enter. Now notice, kind of weird looking graph it gave us. Not even sure how to interpret that. It's interesting that TI-Nspire gave something a little bit different, but I had slightly different numbers there, but I wouldn't have thought it'd make that much of a difference. But again, it just gives you a wrong graph. So if I go back to tab, up arrow to go to Y1, and do a control delete to clean out that line. Again, to put that in correctly, you have to do your x key, caret 3, right arrow to get it out of exponent mode, minus x squared minus 1. And then enter. Big difference in the graphs you come up with. So again, right arrow gets you out of the exponent mode. Actually gets you out of anything that we're going to see that's unique on this calculator. Now usually I show y is equal to x to 1/2. And I do that to demonstrate how do you handle it when you got more than a single number or a single variable up here. Normally what we do is we put parentheses around the exponent. But what we're going to find is this is not necessary with the TI-Nspire CAS. Let's see why. If I press tab to go back here, do my up arrow, and I'll press control delete to clean out the line. Then I'll do my x, and then my caret for the exponent. Now it's up in the exponent right here. So if I do 1 divided by 2, all of it's already up in your exponent, so you don't have to worry about it. And then I press enter, and that gives me my graph. In other words, you do not need to put parentheses on the exponent because you're already up in exponent mode. You just have to remember to press your right arrow key to get it out of exponent mode if you have anything else within the problem. And let's take a look at square root of x. Press my tab to go back there. I do my up arrow, and I do control delete to clean out everything. Now you see above the x squared is a square root symbol. So I do a control x squared, gives me a square root symbol. I'll put in my x key. Now notice I'm still underneath the square root. To get out of the square root, we'll press the right arrow key. That's always good practice. When you're done with entering it, go ahead and get out of it. And I'll follow that convention from now on, even though you could have just went ahead and pressed enter and it would have graph defined. So then press graph, and that gives us our answer. Now you may be looking at that and it's like, well, that didn't change. It's the same as the previous graph. Yeah, because x to 1/2 is the same as the square root of x. Let's look at the cube root of x. Now what I'm going to show you here is how do you handle it when you have any number here. Now when I say any number, I mean 3 and above. Because if it's a 2, it's a square root, and 1 isn't defined, or 0 or negative numbers. So if you have 3 or above, you have 400, 5, 6, 20, 201. That's called your index. Well, press tab to go back here, up arrow, control delete to clean that out. And there it is, above the caret. So if I do control caret, it's a radical with an n. That n represents your index. So I'll put a 3 in here, and you can press the tab. That'll take you to what's underneath the radical. You do your x, and if I press tab, it would go ahead and graph it. So tab kind of performs two different purposes. At first it switched us from the index to what's underneath the radical. Then when I did tab again, it actually graphed it. We'll see a different way of doing that on the next problem. And it gives us something like that. Now let's take a look at the fourth root of x. Even though that's pretty much the same, I always show this in my college algebra class, though we don't use a TI-Nspire currently. Okay, now if I press tab, it'll get rid of that there. If I go to tab again, it comes back here. Come up here, I'm going to do a control delete to clean that out. Now I'll do a control caret to get that. Now if I put a 4 in there for my index, if I do my right arrow key, that'll put it underneath the radical also. And then if I put x, and now do a right arrow key, it will not automatically graph it. It will just keep me in here if I have more to enter. Tab, automatically graphs it and throws it in there, which you may want, may not. Now if I press enter, then that gives me my graph. Fourth root looks very similar to the square root. It's just a little bit closer down to the x-axis. Let's take a look at the absolute value of x. Press my tab to go back here. I do my up arrow. Control delete to clean that out. Now there's a book right here. If you see this book, to the left of it, I don't know what that is, just symbols. But if you choose that, it'll pop up this, and I can down arrow. You may have to right arrow, down arrow, left arrow. You'll have to do something. You want to choose the absolute value, which is the one on the second row, first entry on my calculator. And then press enter, and you see your absolute value on your screen. And if I put in x, and you probably can guess it, to get out of the absolute value, you press your right arrow key. And now if I press enter, that gives me my graph. Okay. Well, let's take a look at y is equal to x plus 2 over x minus 3. Now what I'm demonstrating here is how do you handle fractions in general in your calculator. If you have more than a single number or a single variable on top or bottom, you have to put parentheses around it when you plug it in. So this one, I'll put parentheses around the top, and I'll put parentheses around the bottom when I plug it in. Now if I just had a single x up on top here, I wouldn't need to put parentheses. Doesn't hurt anything, but you wouldn't need it. Other than that, we pretty well enter it as you see it. So I press tab to go back here, up arrow, control delete to clean that entire line out. I'll do beginning parentheses, and then x plus 2. Now notice when I put the beginning parentheses, it went ahead and put the closing parentheses for us. To get out of the closing parentheses, I'm going to press my right arrow key, divided by beginning parentheses, and x minus 3. Now again, it went ahead and put the closing parentheses here, so I just do a right arrow key to get out of that, and then press enter. And this would be your answer. It should look like that, more or less. I won't spend a lot of time trying to sketch that. Now, next one. This is not a basic building block, but it demonstrates something you need to know on your calculator. We got a dash, square root, dash x, dash 3. Dashes. Well, you got one dash here that's a negative, and you got one dash here that's a minus. In general, if the dash is the very beginning of whatever, it's a negative. So this one is the very beginning of our problem, so this would be a negative, one with parentheses around it. This one is the very beginning of our square root, so it'll be a negative, parentheses around it. If your dash is between two things, between x and a 3, for example, it's a minus. Well, you might say this dash here is between the square root and the x. Well, it goes against the first rule I gave you, that if it's the first item in whatever, then it's a negative. So we're going to enter it exactly as you see it. So I'm going to press my tab, up arrow to F1, and then I'll do control delete, put in my negative. Now my square root, so I'm going to do control x squared, and then I'll put a negative x minus 3, and I'll do a right arrow key to get out of the square root, and then I press enter. And that's our graph. Well, let me go back and play a little bit. I'm going to press tab, up arrow, and then I'm going to do my left arrow. Oops. And I'll put it between the negative and the x. Now I'm going to do a delete, so I'm going to do a backspace, wipe that out, and I'll put a minus there. I'll put the wrong dash. And I'll do a right arrow key, clear over there. Notice what happened. Changed it back to a negative, didn't it? Well, let me show that again. Okay, watch that. It's a minus now, isn't it? Let me press enter. Now if I go up, it's back to negative. It fixes it automatically. Pretty cool. It's just like, well, if it fixes it for you, why does it matter then? Just put the whichever one in and it automatically fixes it. Well, let me do a left arrow key. Put my cursor between the minus and the 3. Now let me do a backspace, a delete, and put a negative there instead. And now if I press enter, it's like, whoa, look what happened to my graph. Graph looks entirely different. If I press my tab to go back and do my up arrow, it made it a negative x times a negative 3. So it assumed that dash incorrectly. That's not what I wanted with my problem. So I do a left arrow key to go back here, press my backspace twice, and put a minus there. And now if I press enter, this is why it's important for you to know which dash to put where. Because sometimes it may guess correctly on a TI-Nspire CAS, sometimes it may guess incorrectly. And there's nothing saying that's not what I meant. Maybe I meant that to be a negative x times a negative 3. Anyway, let's look at this one, which is a combination of some building blocks. X to the power of x squared minus 3x plus the square root of x. I think I got that one down. Let me see. Minus 3x plus square root of x, yes. Okay. Normally, if we have more than a single number or single variable in our exponent, we have to put parentheses around it. We don't have to worry about that on TI-Nspire CAS because it's got exponent mode. So let's just start entering it. Press tab, up arrow to go to F1, control delete to clean that out. Then I'll do my X key, I'll do a caret for the exponent, and now I'm up in exponent mode. And now we're ready to enter in x squared minus 3x. So x, and then the x squared minus 3x plus square root of x. So I'm going to do a control x squared for the square root, put my x in. I'm going to press my right arrow key to get it out of the square root, and I'll press my right arrow key again to get it out of the exponent. And press enter. And that gives us our graph. Again, these basic building blocks are used to graph ones like that last one we looked at, or just a combination of different ones. Now, some people like plotting these by hand. They like doing T-charts and creating points and so forth. Let's say you're the best point plotter. That's a word. There was in the previous class. Everybody else was happy with 3 points. You did 9 or 10. And this one, well, we know what that is. That's a parabola. Looks like that. Or maybe it's a heart shape. We just didn't plot enough points. Maybe it comes up like this, and then it comes back down over here. Maybe this comes up like this and comes back down over here. Maybe it comes down over at x equals 500. You just needed to plot 500 points, and you would have saw it come back down. Plotting points is one of the worst methods in the world, unless you already know what a graph looks like. Now think what I'm saying. Why are you even graphing if you already know what it looks like? Now the graphing calculator has its flaws too. Here might be our standard viewing window. So you graph it, do everything correctly, and you still think it's a parabola. You don't realize it's coming back down. Well, I didn't say it's perfect. It's much better than plotting points. It still has its flaws. Some of it you can see with the leading coefficient test, and some of it you just have to go on and take Calc 1 or Business Calc if you want to find out what the true picture of the graph looks like. For the most part, in college algebra, we're satisfied with the standard viewing window. There would be a few problems that don't fit into that, but for the most part, that's what we're going with. And that's basic graphing on a TI-Nspire CAS calculator.